Kirchhoff's laws are fundamental principles in electrical circuit analysis. Named after German physicist Gustav Kirchhoff, these laws provide the foundation for understanding how voltage and current behave in electrical circuits. They are essential tools that every electrical engineer and physics student must master. Kirchhoff's laws consist of two fundamental principles that govern the conservation of charge and energy in electrical circuits. The current law, abbreviated as KCL, is based on charge conservation. The voltage law, abbreviated as KVL, is based on energy conservation. Together, these laws allow us to analyze any electrical circuit, no matter how complex. Kirchhoff's current law states that the total current entering a junction equals the total current leaving that junction. This law is based on the principle of charge conservation, meaning that electric charge cannot be created or destroyed. As a result, charge cannot accumulate at a node in a circuit. Whatever current flows into a point must flow out of it. Mathematically, Kirchhoff's current law is expressed as the sum of all currents entering a node equals the sum of all currents leaving that node. The sigma symbol represents summation. I sub in represents the sum of all currents entering the node, while I sub out represents the sum of all currents leaving the node. This equation ensures that charge is conserved at every junction in the circuit. Let's look at a practical example. Consider node A where currents I1 and I2 are entering, while currents I3 and I4 are leaving. According to Kirchhoff's current law, the sum of entering currents must equal the sum of leaving currents. Therefore, I1 plus I2 equals I3 plus I4. This relationship holds true for any node in any circuit. Kirchhoff's voltage law states that the sum of all voltages around any closed loop in a circuit equals 0. This law is based on the principle of energy conservation. It means that the energy supplied by voltage sources in a loop must equal the energy consumed by the circuit elements in that same closed path. No energy is gained or lost as we traverse a complete loop. Mathematically, Kirchhoff's voltage law is expressed as the sum of all voltages around a closed loop equals 0. When applying this law, we assign voltage rises a positive sign and voltage drops a negative sign. As we traverse the loop and add all voltage rises and drops algebraically, the total must equal 0, confirming energy conservation. Here's a practical example of Kirchhoff's voltage law. Consider a closed loop with a voltage source V sub S providing a voltage rise, and two resistors creating voltage drops V sub R1 and V sub R2. Going around the loop, we have V sub S minus V sub R1 minus V sub R2 equals 0. The positive voltage from the source is exactly balanced by the negative voltage drops across the resistors. Kirchhoff's laws have numerous practical applications in circuit analysis. We use KCL to find unknown currents at circuit junctions and KVL to calculate unknown voltages across components. These laws form the basis of mesh analysis, where we apply KVL to solve complex circuits with multiple loops, and nodal analysis, where we apply KCL to solve circuits using node voltages. Both laws work together to analyze any electrical circuit. Let's recap the key points. Kirchhoff's current law tells us that current in equals current out at any junction. Kirchhoff's voltage law states that the sum of voltages around any closed loop is 0. Both laws are based on fundamental conservation principles: charge conservation for KCL and energy conservation for KVL. These are essential tools for analyzing any electrical circuit. Master these laws to truly understand circuit behavior and solve complex electrical problems.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.